Let's talk about where we see similar figures in the real world, because you might be surprised to find out just how common it is to see things that are similar, geometrically. For example, have you ever built something in Minecraft before? If you made something from the real world, but made it in Minecraft, you had to scale it down to be the right size based on similarity. Nate, for example, built the Eiffel Tower in Minecraft. The actual Eiffel Tower is 300 meters high and 100 meters wide. Nate made his Eiffel Tower 48 blocks wide, so how many blocks high is it going to have to be? Well, to figure this out, we're going to have to set up a proportion. And it's important when you set up your proportion to relate corresponding things in each ratio. For example, we could put the real height of the Eiffel Tower over its real width and set that equal to the Minecraft Eiffel Tower height over the Minecraft Eiffel Tower width. That's not the only way you could set up this proportion. This proportion relates real to real and Minecraft to Minecraft. You could also relate height to height and width to width. So you could say real height over Minecraft height equals real width over Minecraft width. As long as your ratios compare corresponding things, you'll get the right answer. So let's fill in the numbers that we know. The real height of the Eiffel Tower is 300 meters, and its width is 100 meters. The height of the Minecraft Eiffel Tower is unknown. We don't know how many blocks high it's going to be yet, so I'll just leave that as x. But we do know that Nate made his 48 blocks across. So to solve, we're just going to cross multiply. 300 times 48 equals 100 times x, which is 14,400 equals 100x, so x equals 144. And that means that the height of Nate's Eiffel Tower in Minecraft is going to be 144 blocks high. Let's try another one. A diagram of Nora's backyard is shown below. She wants to have a patio installed, which is shown in gray. She wants the patio to be similar, geometrically similar, to her backyard. So not just any rectangular patio, she wants the rectangle of the patio to be the same type of rectangle, similar geometrically, to the size of her backyard. So based on the measurements that we see in this diagram, the length of her backyard is 75 and its width is 125. The length of the patio is unknown. That's what we're going to try to figure out here, but we know that she wants the width of the patio to be 50. So again, we'll set up a proportion to solve this, making sure that our ratios compare corresponding things. For example, we could write a ratio of the patio length over the patio width, and set that equal to the backyard length over the backyard width. In addition to making sure that your ratios compare corresponding things, you also have to make sure that the two ratios compare them in a corresponding order. If I do patio length over width, then I need to do backyard length over width. If I made this width over length instead, then it wouldn't be corresponding overall as a proportion. But again, this isn't the only way that you could set up this proportion. Instead of patio to patio and backyard to backyard, you could compare length to length and width to width, and it'll work the same way. So let's fill in the numbers that we know. The length of the patio is what we don't know. That's what we're trying to solve for, so I'll call it x. And the width of the patio, she wants it to be 50 feet. The length of the backyard is 75 feet, and its width is 125 feet. So to solve, we'll cross multiply. X times 125 equals 50 times 75. 50 times 75 is 3750. Divide both sides by 125, and we get an answer of x equals 30, which means the length of the patio should be 30 feet. Nora is wondering if her house is also similar to her backyard. To figure this out, we'll set up another proportion. We'll set up the length of the house over the width of the house equal to the length of the backyard over the width of the backyard. This time you'll notice we knew all of the numbers. There was no x to solve for. So I'm not going to cross multiply this time. I'm going to reduce each of these fractions. 65 over 100 reduces to 13 over 20. And 75 over 125 reduces to 3/5. And those fractions are, obviously, not the same fraction, so we can conclude that the house and the backyard are not similar. If you're not great at reducing fractions, you can actually cross-multiply to show that they're not equivalent as well. 65 times 125 is 8,125. And 100 times 75 is 7,500. So since I got different numbers when I cross-multiplied, 8125 does not equal 7,500, so that's another way of showing that these two figures, the backyard and the house, are not similar. In fact, there's one more way that you could do it as well if you're not great at reducing fractions. Instead of reducing it to a fraction, reduce it to a decimal. 65 divided by 100 is 0.65, and 75 divided by 125 is just 0.6. I actually almost like doing it better that way, of seeing the 0.65 and the 0.6, because it shows me a little bit better that 13/20ths and 3/5ths, although they look very different from each other, if you simplify them to decimals, 0.65 and 0.6 are actually pretty close to each other. So the backyard and the house aren't similar, but they're not too far off. Our final example has us compare some TVs. Ryan is shopping for either a 24-inch or a 32-inch TV, and he's looking at the overall dimensions, the length and the width of each TV. Little known fact, when you're shopping for whatever size TV, the 24-inch or 32-inch or 75-inch, whatever size TV you're getting, that measurement is actually the diagonal length from one corner across the TV to an opposite corner, not the length or the width. So instead we're going to look at the actual lengths and widths of each of these TVs, and you'll notice the instructions say it does include the plastic frame that goes around the screen. And the question is, are these two TVs, the 24-inch and the 32-inch that Ryan is looking at, are they similar to each other? Well, the 24-inch TV measures 14.4 inches high and 21.7 inches wide, whereas the 32-inch model measures 19 inches high and 28.8 inches wide. So again, when we set up our proportion, we just have to make sure that we're comparing corresponding things in each ratio. For example, if I make my first ratio 14.4 over 21.7, that's comparing the height and the width of the 24-inch TV. So I can set up a similar ratio for the 32-inch TV of its height over its width, which would be 19 over 28.8. So you have a few options, kind of like what we talked about on the previous example. You could reduce, but those are really ugly fractions because they have decimals in them, and it's really hard to reduce fractions that have decimals. So instead, you could cross-multiply, or you could divide. If we cross-multiply, 14.4 times 28.8 is 414.72, and if I multiply 21.7 times 19, I get 412.3. So they're pretty close to each other, but they're not exactly the same thing. So these two TVs are not similar. You could also prove that by just dividing each of these fractions into a decimal instead. 14.4 divided by 21.7 is 0.66359 yada yada yada. It's a really ugly decimal. And if I do 19 divided by 28.8, I get 0.65972 yada yada yada. It is important, especially on fractions as ugly as these two, to give lots of decimal points, because for example, if we had just rounded to the nearest hundredth, they would actually both be 0.66. But if you look at more decimal points beyond the hundredth place, you'll see that they are not the same decimal, and therefore these two TVs are not similar, because their side lengths, including the plastic frame around the screen, were not proportional. So Ryan is wondering which TV gets him more TV for the money. Basically, what's the cost per inch if the 24-inch TV costs $79.99 and the 32-inch TV costs $99.99? So let's set up a ratio that compares costs to size and costs to size of each of these TVs. The cost of the 24-inch TV is $79.99, so I'll put $79.99 over 24. And I'll set that equal to the other TV, $99.99 over 32. Again, you could try to reduce that if you want to, but it's pretty ugly. So instead, I'm going to divide to get decimal versions of each of these fractions. $79.99 divided by 24 is $3.33, and $99.99 divided by 32 is $3.12. So they're not similar because we didn't get the same exact number when I divided. And it turns out that the cost per inch of the 32-inch TV is slightly less than the cost per inch of the 24-inch TV. Therefore, you could say that a 32-inch TV gets you more TV for your money. And that's the basics of what you need to know about similarity in the real world. In our next lesson, we're going to be discussing how do we prove that two triangles are similar to each other.